is yours.
All right, thank you. I guess what that means is I've been around for a long time. Appreciate the invitation to speak with everyone today. There's a lot going on here at SPC, and this is a perfect day to share it, the anniversary of the first successful tornado forecast. So it seems appropriate to talk about what's going on here at SPC, and most importantly, to ask for everyone's feedback on the information that's available so that it can help guide our continued evolution of these services. So just quickly, I wanted to let everyone know, hopefully you know about the internal SPC page, the WOC page. I got a request earlier this morning to make that available for home use during the current crisis, and that's something we're going to look into. There are three really interesting things on this page. I'm only going to talk about the timing guidance, since I think the watch status graphic and the outlook preview graphics are fairly well known. But I would say the timing guidance is one of two major initiatives here at SPC right now. The other being some work on conditional intensity estimates that we hope will add more value to our traditional probabilistic outlooks. If you're not familiar with this, this is a relatively new page from the SPC on our internal WOC page. It's really designed to answer the one lingering question regarding SPC forecasts, and that's the when part on the severe weather risk. It's nationally consistent timing guidance. It does reasonably well, and I'll go into some of the details here in a second. We also have the ability to look at a time series available for any grid point. A lot of capability here, and what we really want is for folks to try it out, give us feedback. We've gotten, I would say, fairly minimal feedback at this point. So either it's a question of it's no good, or folks just aren't aware of it. So I really wanted to stress that this morning. The convection allowing aspects of the HREF, just by its very nature, gives us useful information in a probabilistic sense regarding timing, convective mode, likely coverage, and intensity. These are all very useful for IDSS, and again helps us to answer the question of when. The HREF generally provides reasonable timing. You know, there's the old saying that all models are wrong, but some are useful. The HREF is certainly very useful. In fact, within the HWT last spring, it was subjectively voted as the best convective allowing guidance that folks had access to, and there were quite a few other models available. So it speaks pretty highly to the skill within the HREF. In fact, here's just and there's a lot here, and I'm not going to go into great detail. The bottom line is that the forecasts are very reliable from the HREF. They were compared in the test bed last year with the HURRY and the OU MAP, which is a 10-member ensemble, no mixed physics, I think an ARW core. But in general, the HREF performs very well. So it's a good ensemble, even though it's a collection of deterministic models and their time-lagged equivalents to really use to get to some of the questions that we all want to know. That's when will severe weather threaten? What will the main hazards be, and how can we use that in our IDSS? So we use the hourly probabilistic information regarding two aspects. One is the environment. We actually get that from the SREF, and we get storm attributes from the HREF. The other input is the experimental day one convective outlook in continuous probability form, not the stair-step probabilities that you're used to seeing in SPC probabilistic outlooks. So that's another thing to check out on the SPC WOC page. Increasingly, we want to move to continuous probabilities to show gradients in risk, not just the sort of smoothed out stair-step probabilities that you see today. So in essence, what we're doing attempts to merge the best contributions from the human, which includes the general thunderstorm outline area, and some information on risk with the capabilities of automation. Here's an example from the lower Mississippi Valley Gulf Coast region. This shows the outlook in probabilistic form. And if you click, I don't know if you can see the mouse here, but click on the time series to turn it on. You will see a series of grid points. You can click on any one, and you can see the graph that shows the probability change over time for tornado, hail, and damaging winds. And you can also see the corresponding categorical risk in terms of the shaded area. So it's actually very useful at a particular point to illustrate the potential risk from severe storms. On the WOC page, it encourages folks for internal use only, but I have seen a few WFOs tweet this, and we have no problem with it at all. If it reflects, in your view, what's likely to happen in your area, you're welcome to do that. We certainly appreciate any feedback you get from partners or your own feedback regarding its usefulness. The other thing I wanted to talk about real quick is the notion of the nested MD concept at SPC. This is it's not anything new necessarily. It's more of a shift in emphasis. I think most folks, when it comes to severe MDs from us, are used to seeing watch probability MDs. Those have evolved over the past 5 years or so. We get great feedback on that, not just from other meteorologists, but from emergency managers, public safety folks who just want to know what's the likelihood of a watch in a particular area. But as we get better at interpreting CAM model output, and certainly ensemble CAM guidance, and we have a better idea of the environment in which tornadoes are likely to form through some work that I'll talk about here a bit later, we're trying to focus more on sub-watch scale or meso-beta scale, mesoscale discussions that attempt to highlight corridors or areas of greater risk within a watch area. And just based on the tendency for those to be retweeted, I guess Twitter is sort of the ultimate benchmark for the usefulness of just about anything these days. The meso-beta MDs are quite popular. We see lots of retweets, and I think they're very effective, certainly one tool to get information out regarding where the risk is higher, even once the watch is in effect. And then in the very center there of the MDs over Louisiana, you'll see a very small MD, and I wanted to talk just briefly because I know there's been a decent amount of discussion regarding so-called storm scale or mesogamma MDs, and just talk about the conditions under which we would even consider issuing one here at SPC. So here's the storm scale, or I'm sorry, the mesoscale, meso-beta scale MD. This is from March 3rd of last year, the Lee County, Alabama tornado, which was quite devastating. This is a sub-watch scale, or meso-beta MD, attempting to highlight where the risk for tornadogenesis, potentially strong tornadogenesis, was maximized in the vicinity of a warm front. And when that was issued, the feedback that we received from external partners and from affected WFOs was really quite positive. I think in most cases, we're all looking at the same information, but because of what may be happening in an office with local DSS and outreach, not all of the information that might be available can really be scrutinized carefully. Certainly with mesoscale analysis going on at the WFO, this might be just confirming information, but we at least wanted to make it available and to give you another perspective when you're in or about to enter warning operations. So here's a couple examples of the meso-beta MDs, again, trying to highlight, in most cases, so far it's been greatest tornado risk, but our forecasters have been told, and they embrace the idea of not just focusing on tornadoes. It's probably the most visible aspect of what might go on in a particular event, but it could be extreme damaging winds, such as with the derecho over northern Wisconsin in July of last year, or it could be very large hail. So whatever the severe hazard, if we can identify a corridor, an area of greater risk within the watch, we're going to try to issue these meso-beta scale MDs. And then we have done a handful of storm scale MDs, probably going back to last year on the order of 12 to 15 total. These are fairly small scale and typically highlight an ongoing strong or violent tornado in a situation where the environment should remain favorable and it's likely to continue. To be honest, we've gotten, to use an ensemble term, dispersive feedback, ranging from this is great to you're stepping on the toes of the warning process. And so I just wanted to make clear what our internal guidance is to our forecasters, and also to welcome any discussion. And so internally, these are the conditions under which we would consider issuing the mesogamma or storm scale MDs. So 10% SIG tornado probability or greater almost always exists. There's certainly a tornado watch. There's a tornado warning, most often with the considerable or catastrophic tag already in place. A TDS is present. The rotational velocity and environment data that we're all looking at shows the high probability of EF3 or greater. And I'll explain what the high probability means here in a second. We think the environment's expected to remain favorable, and the SPC lead forecaster agrees that this is a situation where we should issue it. And a lot of the work that underpins this here at SPC is based on the work from Rich Thompson and Brian Smith. It's about a 10-year project as of this year. Over 44,000 lines of rotational velocity, environmental characteristics, and damage indicator points from the DAT tool. And so what you see here are box and whisker plots, again, for a given combination of rotational velocity, environment parameters, what the range of expected wind speeds are. And so in a few of these storm scale MDs, we have put in the wind speeds, and again, these are rare, these are extremely high confidence, essentially confirming MDs, confirming the tornado existence and the likely intensity. Honestly, how I see this playing out over time is this, to me, is the statistical underpinning for IBW decision making, for having confidence in using considerable or catastrophic tags. We would love for this to be in either WarnGen or probably Hazard Services, the evolving warning tool, or in some capacity at every WFO. I think, thinking back to my days in the WFO, this would be really helpful information. We're about to publish the paper. It's been submitted to the AMS to publish. And I really think this is it's decision assistance, it's instant expertise, however you want to look at it. I think it's really valuable. And so in a longer term sense, I think this type of information and the ability to use it in an operational environment rests at the WFO. But we are doing a few targeted storm scale MDs in very highly favorable environments with a likely ongoing stronger violent tornado to illustrate the capacity and just to give some extra visibility to this work. And I guess I went through the slides pretty quick, but I would certainly, if there's time and that's okay, welcome any questions.
All right, thank you, Bill. We'll pause here for a little bit for any questions. Go ahead and raise your hand.